to understand limiting reagents, let's first of all discuss girls and shoes. So you know, of course, that one girl needs one pair of shoes, which is 2 shoes, so that she can become a girl with shoes on. Let's imagine that all girls weigh 50 kilograms or have a mass of 50 kilograms, and all of these shoes have a mass of 0,2 kilograms each. And let's say that we have a situation shown here where we have 7 shoes and 3 girls. And then they put the shoes on. So the first girl gets her shoes, and the next girl gets her shoes, and the third girl also puts on her shoes, and we are left with one single shoe with no owner. So now we have 3 girls with shoes on, and we have 1 unused shoe. So if we look at the masses of the shoes, there's 7 of them, and each of them has a mass of 0,2, so that's 1,4 kilograms. For space's sake, I'm not going to write kilograms. The mass of the girls, there are 3 of them, each one has a mass of 50 kilograms, so that's 150 kilograms total mass. The mass of the girls with the shoes, each combination of girl plus shoe has a mass of 50 kilograms for the girl and 4 kilograms for the 2 shoes. And now we have 3 of them. So 3 times 50,4 is 151,2 kilograms. And then the mass of the unused shoe, there's just 1 of them, it has a mass of 0,2 kilograms. So the total mass of the girls and the shoes before they got dressed, before the reaction, was 1,4 plus 150, which is 151,4 kilograms. And the mass of the girls and unused shoe after they had got dressed was 151,2 plus 2, which is also 151,4 kilograms. So that we see mass has been conserved. The mass before the getting dressed, the reaction, and the mass after getting dressed are the same mass, because we haven't made shoes or destroyed shoes or girls in the process. Matter has been conserved. So these are the actual amounts. That means really how much we have. Now let's rather look at the ratios. Ratios don't mean actual amounts. Ratios are relationships between things. In this case, between 3 things: shoes, girls, and girls with shoes. And we must give it in the simplest form. It doesn't have to be in the simplest form to be a ratio, but that's how we normally write it. So we know that 2 shoes are needed for every 1 girl to make 1 girl which has shoes on. That is the ratio of shoes to girls with shoes. 2 shoes is to 1 girl is to 1 girl with shoes on. That's a particle ratio, because shoes and girls are particles. Now let's convert the particle ratio into a mass ratio. 2 shoes has a mass of 0,4 kilograms. 1 girl has a mass of 50 kilograms. And 1 girl with shoes on has a mass of 50,4 kilograms. So this is now the mass ratio in which these girls and shoes react. 0,4 kilograms of shoes is to 50 kilograms of girls is to 50,4 kilograms of girls with shoes on. Now let's speak about the parts that were actually used in this getting dress. There were 7 shoes actually, but 1 of them never got used. So we only needed 6 shoes for the 3 girls, and we ended with 3 girls with shoes. So the mass of the shoes needed was 6 times 0,2, which is 1,2 kilograms. The mass of the girls was 150 kilograms, and the mass of the girls with the shoes was 151,2. So the total mass required was 151,2. Do you see that's not the same value as what we got over here? Why? Because of that extra shoe, which has a mass of 0,2 kilograms, that will still be left over at the end of the getting dressed. There we have it. Total mass here is 151,2 kilograms too. But in both cases we actually also have the 0,2 kilograms of that extra shoe, but it didn't react. So we can describe it differently to the rest because the other things did react. So now, which is the limiting reagent in this example? Is it the girls or is it the shoes? Remember, the limiting reagent is what runs out first. Which one ran out first as they were getting dressed? This girl came along and she chose shoes. She chose those two. This girl came along and she chose those shoes. And then this one came along, she chose those shoes. Which one ran out first, girls or shoes? You can see girls, because there were still some shoes left over, but no more girls to come and choose them. So the girls are the limiting reagent in this example. And the limiting reagent is the one that will produce which? Less or more of the product if all of it is used up? And you should remember the answer is less. And that's what we're going to calculate now. We're going to demonstrate this. We know that the girls are the limiting reagent in this particular example, and now we're going to show that they produce less if all of them are used up.